I've seen this so many times. This is how most teams build AI systems. They pick tools first, build something that works in demos, but then they can't answer one question that actually matters. Is it actually working? The teams that shape AI systems do it completely backwards. They start by figuring out how to measure success, then design the systems to capture those measurements, and only then they choose the tools. I call this the reverse strategy. Hey, I'm Sandy. I've spent over 18 years designing and scaling data and AI systems for mid-sized companies to Fortune 500 enterprises across finance, healthcare, retail, and software. I help teams bridge the gap between data and AI, turning architecture into real business outcomes. Here, I will show you how to build AI systems that actually work in the real world. Most AI projects start with someone saying, GPT could handle it, or let's try Claude, or even better, they brag about RAG. 3 months later, they have a demo that looks great in meetings, but they can't prove it's actually working or helping anyone. I'm going to show you a real project where we avoided this trap by starting with measurement. First, let's start with what most people get wrong. So here's the typical pattern I see. A team identifies a problem, a use case. Let's say customer support is overwhelmed, let's do something about it. So someone says, let's do RAG. We will use Pinecone and LangChain and maybe GPT. Great. They spend the next 3 months building a chatbot, connecting it to their systems, feeding it their company knowledge. And then demo day arrives. It works beautifully on some pre-canned questions. Leadership gets impressed. They sign off. They launch the chatbot to the customers. And then, gradually, the questions start. How do we know it's solving problems? Why did it give the wrong answer? Is it better than what we had? What's this costing us? And here's the painful truth. They couldn't answer. Not because their AI is bad or they are not smart, but because they built something they can't measure. And this is backwards. The teams that actually ship successful AI, they do it in reverse. They start by defining what success looks like and how they will measure it. Then they design the system, both the data the AI needs and the system to see what AI is doing. And only then do they choose tools, the AI capabilities. Now let me show you why this works through a real example. And I'm going to walk you through everything, all the layers of this process and how each layer fits into the other to drive real business outcome. And this is how you build AI that actually survives the contact with reality. I worked with a retail bank on a customer support chatbot. Think what questions users would ask. What's my balance? Can you refund this fee? Show me my recent transactions? And so on and so forth, right? So when they came to me, they had already decided on the technology. They told me, we are using GPT with LangChain. We are putting our policies into Pinecone. We just need help launching this solution in the cloud. So I said, wait, let's step back and answer these 3 questions to me. 1, how will you know if the chatbot is making correct decisions about refunds? 2, when something goes wrong, how will you figure out why it went wrong? And 3, how much does each customer question cost you when you use AI? Silence. They didn't have the answers. Because those questions don't come up when you start a project by picking tools. They come up when you start by figuring out measurements. Now, I followed a process. I call this process the reverse strategy framework. It has 3 layers. I will walk you through it one by one with the example. Layer 1, define the metrics. Before writing any code, before choosing any model, before touching any database, we defined what working actually means. We identified 4 categories: AI performance, business results, safety and compliance, cost. For AI performance, this chatbot needed 85% accuracy on fee refund decisions, under 30-second response time, and correct handling when customers had multiple accounts. And what did it actually mean to the business? The business wanted 60% of questions to be handled by the AI without any human assistance. It wanted reduction in average response time by 40% and keeping customer satisfaction above 4.2 out of 5. Now this is banking. Regulation matters, so safety and compliance is paramount. They needed 0 leaks of customer information, obviously. 100% compliance with fee refund policies, and every money decision must have a complete audit trail. In terms of cost, their human support costed $5 per question. That included the labor cost, the software, overheads, etc. For AI to be worth it, we needed the cost way less. The target was under 50 cents per question. We did some back of the envelope calculations and we were confident that that could be achieved. Now, here's what happened when we defined these metrics upfront. We immediately discovered three massive problems with their original plan. Problem one, they had no way to measure accuracy on fee refunds. Their knowledge base had general policy documents, but no examples labeled this customer should get a refund versus this customer shouldn't. They were about to launch a system with no test cases against it, no ground truth. Problem two, they couldn't trace what the AI was doing. If the chatbot said, I have refunded your fee to a customer and it was wrong, they had no way to see which policy it looked at, which balance it checked, why it made that choice. Problem three, about 30% of their customers have both a checking account and a savings account. Their original plan did not include instructions to direct the AI which account of the customer it should use when the customer says, check my account. In general, right? So the customer doesn't specify which account. Now, all of these three problems were invisible when they started by picking tools. The moment we started defining measurements, they became obvious. Now, these are just three examples. So many more come up when you start by defining your measurements. This is the power of layer one. Moving on to layer two, building the foundation. Now here, you're designing two things at once. The data your AI needs to answer questions, so the original outcome, and the tracking system to see what AI is doing. For this banking chatbot, our measuring requirements from layer one forced us to design both. Let me show you the complete setup. Starting with the data and AI needs. Let's call it use case data. For this, we needed to make few decisions. Decision one, real-time account data. To answer account balance questions and validate fee refunds, we needed live access to customer accounts. Their core banking system had the data, but no easy way for a chatbot to ask for it. We had to go through some security approvals and some technical challenges to build a connection with 2-second response time from account lookups. For simple and frequently asked questions like what's my balance, we added a secured caching layer to reduce the system load. But for money actions, for transaction actions, for refund actions, we did not use caching. We had to directly access the database in real time. And these decisions directly came from our measurement requirement. To check if the chatbot handles multiple accounts correctly, we needed transaction-level accuracy. Decision 2, knowledge-based setup. They had already planned to use a vector database. But here's the difference now. We organized it to support measurement, not just retrieval. And what do I mean by that? Let me explain it with an example. Now, their original plan was to dump all 45 policy documents into a database, Pinecone, find the 5 most similar chunks, send them to the LLM, depending on the query. There was no way to measure if it found the right policy, no way to see which section of the policy was used in the retrieval. In our approach, we broke down each policy document into logical sections by rule, not by arbitrary chunking sizes. For each section is tagged with details. Think metadata, like policy ID, when it became effective, what type of rule it is, who is the owner, etc., etc. When the chatbot retrieves a section, we log which sections were found, how relevant they were, which one was actually used. This let us measure two things separately. Is the search finding the right sections from the documents, the search accuracy, and is the AI interpreting the policy correctly? That's more about reasoning. Two different failures, two different measurements. Now, you might ask, what's the advantage of doing that? Here's why measuring separately matters. I'll give you an example. In month 2 after launch, their accuracy on overdraft protection fees dropped. We pulled the logs and we saw that search was working fine. The AI was finding the correct policy documents and the sections with a 9-2 relevance score. which is pretty high. So retrieval was not a problem in this case. The problem was reasoning. The policy said customers are eligible for a refund within 24 hours of posting. The AI was calculating 24 hours from when the overdraft occurred, not from when the fee was posted to the account. And those are two different timestamps. Because we could see the full trace, which policy was retrieved, what data was checked, how the AI calculated the time, we knew exactly where the failure was. Not the search, in the reasoning. Because we could measure search quality separately from reasoning quality, we knew exactly where to fix it. We clarified the instructions to the LLM, not reorganize the documents. Without this separation, we would have wasted time fixing the wrong thing. Decision 3. Creating test cases. Remember, they had no labeled examples to measure against. We worked with their compliance team to label 300 historical fee refund cases. These are cases handled by actual human beings. Out of the 300, we collected 100 labeled cases where the refund should have been issued. We collected 100 where refund shouldn't have been issued. And we collected 100 edge cases. We captured the reasoning, the policies that applied, and the account conditions. This became our testing foundation. Every changes in prompts, updates, model changes, policy updates, we would first run all of those changes against these 300 use cases. If the pass rate was below 85%, we wouldn't let the change go live. And that's how we prevent making things worse. Now that's the data that AI needs to answer questions. But we also needed to design the tracking system to see what's actually happening inside, what the AI is actually doing. This has to be built from day one, by the way, not added later. And this brings us to our decision 4 in the layer 2, a system that tracks every step the AI takes. To measure fee refund accuracy, for example, and debug wrong answers, we needed to see everything. Every system it called, every piece of reasoning, every safety check. We built tracking where every customer interaction creates a record with individual entries for each decision point. Each entry logs what went in, what came out, how long it took, and whether it succeeded. When the chatbot makes a wrong decision, we can replay the exact sequence and see it called the transaction system, it called it 3 times instead of once, it used a wrong time zone for timestamps, it compared pending deposits against posted deposit requirements, and all of these bugs come up when you put tracking in place. Without tracking, it is invisible. With tracking, we found and fixed them in hours instead of weeks. Decision 5, conversation history storage. To measure whether the chatbot correctly handles check my checking account versus check my savings account, we needed to see the full conversation, not just individual messages. We built storage with 30-day retention. Each test can replay the full conversation context. We can measure conversation level quality, not just single level accuracy. And here's the added benefit. When a customer escalates to a human agent, that agent can see the full chat history with all the context. That alone improved handoff quality by 35%. Decision 6, policy versioning. Policies get updated all the time. To evaluate fee refund decisions made last month, you need to know which policy rules applied at that time, not today's rules. Every decision record logs policy version and account snapshot. Our system can replay this decision under the exact same conditions, same data, same rules, same context. This makes our measurement reproducible. So here's the complete layer 2 for you. Think about 2 broad needs here. The data foundation that the AI needs to serve the actual business outcome, and the designing of the tracking system, the step-by-step logging, the conversation storage, the policy versioning, to make sure you understand what the AI is doing. Your measurement requirements shape your entire system. This brings us to layer 3, AI capability selection. Only now, after defining our metrics and building systems to capture them, do we get to layer 3, picking the AI tools. And here's what's interesting. When you do the first 2 layers right, the tool choices become obvious. For this banking chatbot, our measurement requirements told us exactly what we needed. We needed transparent reasoning, so we could see why the AI made each decision. We needed reliable system calls, so all the money actions, the refunds, the transactions, we had to make sure that they happened correctly. And we needed real-time safety checks, so we could catch violations before responding to the customers. Those requirements drove our choices. We used Claude JSON output for reasoning because we needed to see the AI's decision-making process and reliable passing of data between agents, not just the final answer. We built a protective filter for safety checks because our safety requirements needed pre-validation, not checking after the fact. We connected deterministic banking systems for lookups because approximation is not acceptable in financial services. Now, when I talk about this to customers, I get these questions many times. Why did we organize the knowledge base the way that we did, also known as why did we do RAG versus retraining the model? You see, our measurement process told us policies change monthly. Retraining would require updating the model every time, which is expensive, slow, and makes it impossible to see which version of the policy was used for a specific decision. Our approach lets us update the knowledge base instantly, just reindex the new policy, and we can see exactly which policy version was retrieved. Plus, it gives us citations. We can show the customers, according to policy 4.2, effective March 1st, your fee refund is approved. That citation meets our compliance requirements. Retraining can't do that. It's a black box. And because we had already built tracking in layer 2, we could see everything from day 1. When we launched, we immediately spotted the triple call bug I mentioned about. We caught it first week. We fixed it. We reduced response time by 380 milliseconds and cut cost by 12%. Our safety requirements said zero information leaks. Because we designed for this in layer 1 and built safety checks in layer 2, we caught 47 instances in the first month where the chatbot tried to include account numbers in responses. The filter blocked it, every single one of it, before it reached to a customer. You see, most AI projects fail not because the technology doesn't work, but because teams can't measure whether it's delivering value. Leadership asks, is this working? And the team has no answer. In our use case, the bank had a dashboard updated in real time. It showed queries handled, customer satisfaction scores, cost per query, deflection rate, quality issues, etc., etc., with alerts tracking every metric. Every Monday, leadership sees these numbers. They make decisions based on data, not guesses. Let me give you another example to make this more clear. In week 6 after launch, accuracy on fee refunds dropped to 81% from 87%. That metric triggered an alert on the dashboard. It was caught automatically. The support team was informed instantly. Because the tracing was available, they could trace it to a policy change that wasn't in the knowledge base. They fixed it in 4 hours. Accuracy was back to 87% in 24 to 48 hours. Here's another. In week 11, customer satisfaction on balance transfers was lower. Suddenly it went to 3.8 out of 5, where the normal was tracking around 4.4 on average for other query types. They looked at the conversation logs and found out that the AI was giving technically correct answers, but the answers were complex and confusing to the customers. So they simplified the response template. Satisfaction went up to 4.3 in the next couple of days. So you see, every improvement is driven by actual measurement, showing which query types have lower accuracy, which customer intents cause confusion, which knowledge sections return low relevance. This is what happens when you design for measurement from day 1. You can see what's happening, you can fix what breaks, you can make it better. So let's bring it all together. Here's what you can do with this. Before your next AI project, use this as a checklist. The reverse strategy framework, 3 layers in order. Layer 1, define success metrics. This is about your AI performance, business results, safety and compliance, cost limits. Be specific. 85% accuracy on fee refunds with costs under 50 cents per query. That is measurable. Don't say better customer experience. That's vague. That's not measurable. Layer 2, define the foundation to enable measurement. Remember, here you're building two things. One, the data foundation to serve the actual AI use case and outcome, and the tracking system with all the observability data that helps you understand what's actually happening inside AI and how the AI is making decisions. Layer 3, build AI capabilities. Only after you know what you're measuring and how you're capturing it do you choose models and frameworks. Let your requirements drive your choices. We chose Claude for transparency, knowledge-based organization, or RAG for policy flexibility and citations, a proactive filter for safety. The model is the easy part. The data and measurement system is the hard part, and that is your competitive advantage. Now, I know some of you are thinking this sounds like more work upfront, and you're right, it is. Would you rather spend 2 weeks designing measurements before you build, or spend 6 months firefighting, debugging a system you can't see into after you launch? Would you rather walk into your CFO's office with a dashboard showing 60% deflection, 4.4 customer satisfaction, and 2.2 cents per query, or walking and say, we think it's working, but we are not really sure how to measure it? Which one do you think would stick? If you can't measure it, you can't improve it. And if you can't prove it's working, you can't defend the investment. I've created a free template that will walk you through this exact framework, all the 3 layers. You can use it to either build your next AI project or even create a business case that you can show to your leadership. The link is in the description. If you want deep dives in each of these layers, I am breaking them down in upcoming episodes. Please subscribe to this channel and you will get notified when I release another episode. Thank you very much for watching.